Today we are going to deal with data mining classification algorithms based on distance. At the end of this session, the student will be able to demonstrate various classification algorithms that are distance based, and they will be able to compare between them. As we have seen, data mining algorithms extract most important patterns from the data set. So the strategy that is going to be used here is that each item is mapped to the same class is more similar to other items in that class. So similarity between items in the same class is more than similarity between the item from one class and another class. So similarity or the distance between, which we call as difference between two items, may be considered as a measure to identify a likeness of different items in the database. Here we use similarity measure, which is simpler for classification since the classes are known well in advance. If definition is in the form of a information retrieval query, the classification problem is determining similarity between each tuple and the query. So we are going to find in all this orientation a distance measure which is going to indicate how similar are data items to put it into a similar class. So a simple approach is based on the assumption that each tuple Ti in the database is defined as a vector Ti1, Ti2 up to Tik of numeric values. Each class Cj is defined by the tuple Cj1, Cj2 up to Cjk of numeric values. Here we are considering simple numeric values only. Then we define our approach given a data, because these data items are going to be then be tested for their values to be put into different classes. So this database, which is made up of tuples T1 to Tn, where each tuple Ti is a vector Ti1 up to Tik and contains numerical values and a set of classes C1 to Cm. So there are m classes where each class Cj is also a vector. Cj1 up to Ck has the numeric values, and the classification problem is now to assign each tuple Ti to the class Cj such that the tuple Ti will be occurring in the class Cj is always going to be greater in similarity, okay, for all the CLs which are element of C, where the class CL and CJ are different. So similar tuples having minimum distance between them, having more similarity values, will be put into a particular class. So what is the method used here? For similarity measure representation, we create a vector for each class which we have to determine, and we calculate the center for each region, and we place each item in the class where it is more similar to the center of the class. So we find the distance between our item value and the center of the class value. So the centers of all the classes are calculated. Then we give an input tuple which has to be classified, and the output that we have to generate is a class. And the algorithm goes by defining the distances between the tuple and the item in the center. And if it is less than the value which is defined to be distance, then we put that particular tuple into that particular class. So this is how it looks graphically, where class A, all the items represented by x's are at the same distance from CA. For the class B, there will be some other distance. For the class C, there will be some other distance. And thus, we are creating three classes A, B, and C based on the distance the particular data items or tuples have from the center of the class. The next method, which is distance based method, is the k nearest neighbors. So we try to find out the distance between our points and the neighbors. And all the neighbors which have same distance from our particular point of interest are going to be considered as nearest neighbors and going to be put in the same class. So the assumption is entire training set includes not only the data in the set but also the desired classification for each item. So the training data becomes the model. For the classification of new items, distance of each item in the training set must be determined. And we find the k closest entries in the training set, which will be treated as neighbors for further consideration. Now, this new item, which is placed in the class containing most items from the set, is depending on the k closest items which are considered to be neighbors. So we look here at this graphical representation and we see that the x's which are joined by the dotted line to the data item t, which is our tuple of interest, is having all the same distances, the closest neighbors. Okay, then we go for furthermore neighbors, then the third furthermore neighbor, and define k classes. Okay, so depending on the neighbors, okay, we define such a sort of a distance based algorithm. Here distance is the criteria to define the elements in a particular class. So distance based algorithm goes by using a training data, the number of neighbors which are k placed at the same distance, the input tuple to classify taken as t. We find the distance between these tuples and the neighbors, and those that have the same distance are going to be put in the same class. So we are going to define it as the class C, small c. So we have the k nearest neighborhood algorithm working on this particular distance, and when the distance is less than equal to that of the particular neighbor, we are going to consider that those particular nodes, k nodes, as our neighbors, and we are going to find a similarity between these particular items and put them into our particular data set. Okay, and generate a set of tuples which have to be put into that particular class. So the k nearest neighborhood technique is extremely sensitive to the value of k, where the thumb rule goes that k is always less than equal to square root of capital N, the number of training items. For our references, we have used thank you.